write the relation R is equal to x set x cube such that x is a prime number less than 10 in roster form. We have to write this in roster form. So how can we write this in roster form? Let's do. What is x here? X equal to the prime numbers less than 10. So what are the prime numbers less than 10? 2, 3, 2, 3, 2, 3, 5, 7. Then what is x cube here? X cube is equal to 2 cube. 2 cube is equal to 8. Then 3 cube. 3 cube is equal to 27. Then 5 cube. 5 cube is equal to 125. Then 7 cube is equal to how much? 3, 4, 3. So these can be write in roster form. We can write this in roster form. How can we write this in roster form? Let's check. R is equal to, how can we write? R is equal to set 2, 8, then 3, 27, then 5, 125, then 7, 3, 4, 3. So what is the relation here? R is equal to 2, 8, 3, 27, 5, 125, 7, 3, 4, 3. These are the ordered pairs. Okay. So roster form of this relation is what? R is equal to, we have to write this in ordered pairs. Okay. 2, 8, 3, 2, 5, 125, 7, 343. This is the roster form. Isn't it? Question number 8. Let A is equal to x, y, z and B is equal to 1, 2. Find the number of relations from A to B. So how will you do this one? First we have to write A cross B, we have to write. Then what is A cross B here? A is equal to what? Set, you have to write the set x, y, z cross. What is the sign here? Cross 1, 1, 2. This is the set. Then what is A cross B here? We have to write the elements of A is pair with the elements of B. So x1, then comma x2, comma y1, y2, z1, z1, comma z2. Okay. So what are A cross B? A cross B is equal to, we have to pair with all elements of A is pair with all elements of B. So we get like this: x1, x2, y1, y2, z1, z2. Then you have to close with the curly bracket, isn't it? Okay. 1, 2, 3, 4, 5, 6 elements are here. So number of relations from A to B are B is equal to 2 to the power 6. Why? How many elements are here? 1, 2, 3, 4, 5, 6 elements are here. So we can write 2 to the power 6. That is, we can write number of relations from A to B. That is, we already know that number of A cross B, number of elements in A cross B is equal to number of A cross B. We already know that number of A cross B is equal to 6 elements. So number of relations from A to B is equal to 2 to the power 6. Is it clear for you? Number of relations from A to B is equal to 2 to the power 6. How you get 6? Number of elements in A cross B is equal to 6. So number of relations from A to B is equal to 2 to the power 6. Or we can say number of relations is also called subset of A cross B. Isn't it? We can say like that way also. Is it clear for you? Okay. Question number 9. Let R be the relation on Z defined by R is equal to set AB such that AB belongs to set A minus B is an integer. Find the domain and range of the relation R. Solution. We already know that difference of two integers is always an integer. For example, 4 minus 2. This 4 is an integer, 2 is an integer. The difference 4 minus 2 is equal to 2. So 2 is also an integer. Example. Okay. So we can write domain is equal to what is domain here? Domain is equal to set. Set means what? Integers. And domain is equal to set. Domain of this relation is equal to, you have to put this in bracket, domain of R is equal to set, and range R is equal to set. Okay, is it clear for you? Okay, difference of two integer numbers is always an integer. Difference of two integers is always an integer. For example, if you take 4 and 2. Okay, another example, if you take 4 minus 2. So 4 minus 2. So 4 plus 2. 4 plus 2 is equal to 6. 6 is also an integer. So that is why we already know that difference of two integers is always an integer. So domain of relation R is equal to Z and range of relation R is equal to Z. Is it clear for you? Thanks for watching.